See, gentlemen, today I would like to discuss parallel combination of resistor. In the last class, as I discussed about the what is resistor. Resistor is an electronic component which opposes the or which obstruct the flow of electric charge or flow of electric current, which is known as the resistor. So while dealing with the circuits, the resistors can be arranged or resistors can be clubbed or resistors can be mixed into three type or three groups. First one is that series combination of resistors. Combination means you have to group or mix, is it? Second one is that parallel combination of resistors. Third one is that series parallel combination of resistors. Series parallel combination of resistor is also referred as the mixed combination of resistors. So, however, as I said that in the last class, mixed combination of resistor, it is not prescribed for the syllabus. So, therefore, I don't want to use this topic. Now, as you know that in the last class we have completed that expression for the equivalent resistance in series combination of resistors, is it? So today I would like to discuss about the parallel combination of resistors. So the question is that when the two resistors are said to be connected in parallel, as I said that so if I give two resistors, I will ask you to combine in a parallel combination. So if I ask like this, it is very difficult to arrange the in parallel. So in order to arrange them in parallel, you have to know the when the resistors are said to be connected in parallel. You have to know the description of the parallel combination of resistors. Two or more resistors are said to be connected in parallel if they are connected between two given points. So you see that we are considered here two resistors. This resistor, you can say that R1 is the first resistor. This is the R2 is the second resistors. We are considered only two resistors only, is it? Two or more resistors are said to be connected in parallel if they are connected between two given points. The question is that what are the given points here? A and B are the two given points are there. Two or more resistors. Two resistors, they were connected between two given points. I mean that all the terminals of the resistors, if they are connected between two given points, such a combination of resistor is known as the parallel combination of resistors. Parallel combination of resistors. Now you see that simply by connecting the resistors in parallel, you can't maintain the current in the circuit. So in order to maintain the current in the circuit, so what you have to do that? So you have to connect a battery. So what is the role of the battery? What is the function of the battery? So battery develops or battery produces the what potential difference. So as soon as potential difference form, electric field form, as a result charges begins to flow in the circuit. Say from this battery, positive terminal battery, I ampere of main current is generated. So that main current reaching at the junction A. Junction is a point at which three or more conductors are meet. That point we are calling that junction. So you might see that you heard that what is junction. So saying you can say that we can't say that Gulbarga junction because Gulbarga is in a station. So you see that what is the difference between Wadi station and Gulbarga station. So you see that where the Wadi station, three railway tracks they are meeting. So likewise, if three or more conductors, if they are meet at any point, so that point we are calling that junction. So in this circuit we will find that two junction, this is the A junction, this is the B junction. Here also three conductors they are meeting, here also three conductors are meeting, three wires are meeting. Therefore in this circuit there are two junctions are there. So that know that, as I said, that from this cell main current is generated. So main current is I ampere of main current is generated. That main current on reaching at the junction, it divides into two parts. I mean that a part of the current it flows along R1 and remaining part of the current it flows along R2. So once again I1 and I2 they will going to combine at the junction B. So once again on combining I1 and I2 you will get the once again main current. As you know that current is not leak at any point of the any part of the circuit. So how much current is generated from the, how much current is leaving from this positive terminal, same amount of current coming at the what negative terminal of the battery. So in this way continuously charges are flowing in the circuit. The basic just we have seen that, so when the two or more resistors, when the two resistors are said to be connected in parallel. So you have to know the definition. Two or more resistors are said to be connected in parallel. I will write here. Two or more resistors are said to be, two or more resistors are said to be connected in parallel if they are connected between two given point, connected between two given points, or these given points on applying certain PD, across the combination of resistors, same current flowing through the each resistor, So you see that essential component of this definition is that there should be two given point, minimum there should be two conductor. These two conductor you have to connect between two given point. So if you arrange like this, we are saying that parallel combination, is it? So this is the combination of resistors. So you can take three resistors, you can add like this, so this is what R3. So like this you have to connect between R1, R2, R3 is also connected in the what, between two given point. For the conveniency, we are considered only two conductors which are connected in parallel. So as I said that when we are saying that these two resistors are connected in parallel, when we are saying that these two resistors are arranged in the parallel. So what is saying that two or more resistors are said to be connected in parallel if they are connected between two given points. You see, these are the A and B are the two given points. These two ends of all the resistors were connected between two given point. This is nothing but the parallel combination of resistor. For this combination of resistors, you have to applying in a certain PD. So by introducing a battery, you can form the potential difference across the across the terminals of across the ends of the resistors, is it A and B end. As a result, what happens that the electric current will going to flow in the circuit. Say I1 ampere of current it flows along R1 and I2 along R2 as I said it. So now let us see, I would like to discuss about the first point is that you have to draw the circuit diagram. Second point is that when we are saying that two resistors are said to be connected in parallel. Third point is that you have to describe about the circuit diagram. So you are considered two resistors. What are those two resistors? R1 and R2 are the two resistors. Consider two resistors R1 and R2 are connected. How they are connected? Are connected in parallel as shown in the figure. This figure represents this figure shows the parallel combination of resistor. So this is what the parallel, I mean that you are considered two resistors which are connected in parallel. Is it? These two resistors are connected in parallel as shown in figure. So across this combination say that what a battery is connected. So let so since you are connecting battery what it does, it it produces the potential difference. So let V be the PD potential difference. Let V be the PD. Let V be the PD across the across the across the combination of resistors. So what happens that as a result I ampere of current flowing in the circuit. I ampere of current is flowing. So this I ampere of current on arriving at junction A, I ampere of current on arriving at the junction what A, at the junction A splits into or divides into two branches. I1 ampere of current, I1 is flowing along R1. Similarly, I2 is along R2. So what the description say that this is about the description of the circuit diagram. This is a complete circuit diagram. If you have drawn that circuit diagram, so you will get 1 marks. So whatever that you are considered two resistors, these two resistors are combined, arranged in the parallel between two given point. So for this combination of resistor, a battery is connected. As a result, I ampere of current is generated. That current on reaching at the junction is split into two branches, I ampere along R1 and I2 ampere along R2. So in this way, the current is flowing in the circuit. So now this is the description of this. Now from the figure what we concluded that from the figure I can draw the conclusion. So from the figure I can write it. See, you see that from the figure, what is the conclusion you will write? Main current is equal to sum of the branch current. Where we get main current? At the point A junction, or at the junction A. Junction is a point where three or more conductors are meet, which is known as the junction. In this circuit, there are two junctions are there. At the A junction, the main current. So this is nothing but the main current. So from the figure, what I can write it? So main current is equal to sum of branch current, that is I1 and I2. So I can give an analogy for this. So I can give an analogy for this. Say this is an two water canals are there. Imagine that this is an two water canals are there. This is the main canal. This is the two sub canals are there. This is the main canal. You can say that in 1 second 100 cubic meter water is flowing. So in 1 second this much water is flowing in the main canal. So 50 cubic meter water per second. So it flows along, say that this is the A canal, this is the B canal. 50 cubic meter per second in this canal. So you want to know that these are the, you see that if you want to know that main current, so what you have to do that, you have to add the sub canal water flowing. So sub canal, in this A canal 50 cubic meter water is flowing, in the B canal also 50 cubic meter. On summing that 50 will get that 100. So likewise main current is equal to sum of the branch current. So the content is that the main current is always equal to sum of the branch current. From the figure you have drawn the conclusion that main current always equal to sum of the branch current. Apart from that, we can get a message from this, that charge is neither conserved nor, so charge is follows the law of conservation of, charge is follows the conservation of, so this law of conservation of charge. Now let us see. So you can call that, give the number for this equation 1. This is an equation 1. So now what I have to do that? So our basic aim is to that you have to get an expression for the equivalent resistor in parallel combination. So you need an expression for equivalent resistor in parallel combination. In yesterday class we have seen that equivalent resistor in series combination. Likewise, we want to require an expression. We want to arrive an expression. In order to arrive an expression, so what you have to do that? So for this branch, this is the first branch, this is the second branch. For this branch, you have to apply the Ohm's law. Apply Ohm's law. Apply Ohm's law. So for according to Ohm's law, you see that from this first branch, V remains constant. In the parallel combination, PD will be remains constant. So parallel combination potential difference, that will be remains constant. So I think that was me. So in parallel combination, you see that PD will be remains constant, and series combination current will be remains constant. Keep in mind, if I written anything mistake in that definition, so you make it correct. Applying Ohm's law, what it says that V is equal to I into R, is it? So we need an expression for I1. So this is the general expression this general expression you can extend for this specific case. I mean this specific branch. So where the variables are I1 and R1 and potential difference is V. So we need an expression for current. So therefore this expression you can write it is I1 is equal to V upon R1. Similarly, I can write it as I2 is equal to V upon R2. So these two values you have to substitute, above values you have to substitute in equation 1. Above values, substitute in equation, substitute in equation 1. So on doing so, what happened on that? So you see that, so I is equal to, so in place of I1 I can write it is V upon R1. In place of I2 I can write it is, that is V upon R2. So this you can call it equation 2. Give the number for this, then you can call it equation 2. Now I want to remove these two resistors. In place of these two resistors, I would like to connect a single resistor so that I can draw the same amount of current as that of the combination of resistors. In the presence of two resistors, say we are drawing that 1 ampere of current from this battery. Is it? So now you remove these two resistors, now you connect a single resistor so that if you are able to draw the same amount of 1 ampere of current from this cell, then we are saying that this resistor is equivalent resistor in in parallel combination. So first of all, you have to write that what is the equivalent resistor in parallel combination. It is nothing but a single resistor. Instead of using that two resistor, you are using that single resistor. It is a single resistor. What it does? It replaces the combination of the resistors and it produces the same effect as that of the combination of resistor, which is known as the equivalent resistor. So equivalent resistor in parallel is equal to the single resistor which replaces combination of resistors produces same effect as that of the combination of resistors. Equivalent resistor in parallel is the single resistor which replaces the combination of resistor and produces the same effect as that of combination of resistors. So it is denoted by equivalent resistor in parallel combination is denoted by the symbol Rp. So in order to differentiate between Rs and Rp, Rs represent the equivalent resistance in series combination, whereas Rp represent the equivalent resistance in parallel combination of resistors. So now, in order to find the equivalent resistors, equivalent resistance, so you have to draw the another circuit. That is what equivalent circuit of parallel combination of resistors. So according to the explanation, so you have two equivalent resistor is a single resistor which replaces the combination of resistor and produces the same effect as that of the combination of resistors. Now from this explanation I can able to draw the equivalent circuit in parallel combination. This circuit you are calling that equivalent. Equivalent means equivalent circuit, in which case in parallel. So this circuit is equivalent to this. So here instead of two resistors I am considering only single resistor. That single resistor is designated as Rp. The resistance of this single resistor is designated as Rp, and for this, in order to maintain the current in the circuit, I have to connect a battery. This is a battery, positive terminal of the battery, whereas this is the negative terminal of the battery. So since you are connecting a battery to this circuit, what happens that this cell generate I ampere of current. Say this I ampere of current. Whenever the current is flowing through the any circuit element, what happens that PD will going to form the across the circuit element. So as you know that resistor, inductor, capacitor, these are all the circuit elements, is it? Whenever the current is flowing through the circuit element, a PD, a potential difference, will going to form across the resistor. So this is the PD which will form across the RP. Now let me know that. So once again you have to apply the Ohm's law in order to find the current in the circuit. So from Ohm's law, so you have to apply the Ohm's law from Ohm's law. So as you know it, general expression for the Ohm's law is V is equal to I into R. So I have to bring an expression for I. I have to bring an expression for I. So in order to bring an expression for I is equal to V upon Rp. So you see that this is a current, I is current, the potential difference across Rp is V, resistance is Rp. So therefore this you can call it equation 3. So you see that one thing you will find that lot of similarity between the series combination and parallel combination. I mean that similar treatment is there in series and parallel combination of resistors. There also we will find that 3 equations. Here also we will find that 3 equations. There also we are equating equation 2 and 3. Here also